Let's start with a simple equation like this one, where we have x plus a number equals another number. Now, in order to solve the equation, in order to answer a question like this, you need to find the value of x. X could be any number. It could be 1, 2, 3, 4, 100. We don't know what x is unless we solve the equation. Here I know that x plus 5 equals 7. The easy way to do this is to move the plus 5. Because basically what we want to do is get rid of anything next to the x. So we're going to move the plus 5 to the other side of the equation, and once we move something to the other side, we change its sign, so instead of plus 5, it becomes minus 5. We can rewrite this as x equals 7 minus 5. X equals 2, because 7 minus 5 is 2. Let's take another example. X plus 2 equals 59. X plus 2, we want our answer to be x by itself equals something. So we must get rid of anything next to the x. Since it's a plus 2, it moves to the other side as minus 2. So we can rewrite this as x equals 59 minus 2. So x equals 57. Let's do another one with fractions. X plus 2 over 3 equals 5 over 3. We want to get rid of the 2 over 3 with the plus sign. So we move that to the other side as minus 2 over 3. We can rewrite this as x equals 5 over 3 minus 2 over 3. X equals 3 over 3, which is 1. How do we solve a question like this? Remember, in order to solve this equation, in order to find the answer, we need to find out what x equals. In order to have just x before the equal sign, we have to get rid of whatever's next to it, which is minus 5 right here. We move the minus 5 to the other side of the equal sign, and we change its sign. So instead of minus 5, it becomes plus 5. We can then rewrite this equation as x equals 3 plus 5. X equals 8. Let's try another one. Here we have x minus 10 equals 39. Again, we want x by itself equals something. We want to find the value of x. So we need to get rid of anything that is next to the x. Here we have minus 10. Move it to the other side of the equal sign. Change the minus into plus, so you have plus 10. X equals 39 plus 10. That means x equals 49. Let's try a harder one. Here's one with fractions. X minus 5 over 7 equals 12 over 7. X equals, we want to get rid of the minus 5 over 7. So we bring it to the other side, change the sign from minus to plus, keep the 5 over 7 as it is. Now you can rewrite this as x equals 12 over 7 plus 5 over 7. X equals 17 over 7. And of course, if you go a further step, you can change 17 into 7 to a mixed number. Let's learn how to answer a question like this. We want to find the value of r. So I need to get r equals something by itself. In order to do that, we must get rid of anything next to the r like we learned before. Now, next to the r right here, I have times 5. Times 5 goes to the other side of the equal sign as divided by 5, because we have to reverse the sign, and the opposite of multiplication is division. So we can rewrite this as r equals 15 divided by 5. What is 15 divided by 5? It is 3. So r equals 3. Now, let's do another one that looks slightly different. Look here. What if I told you 5r equals 15. What does this mean? It means 5 times r equals 15. That's the same as saying r times 5 equals 15. It doesn't make a difference. 5 times r is the same as r times 5. So the concept is the same. We still want to get rid of this 5. But in order to get rid of this 5, we have to move it to the other side of the equal sign. But right here, there is no sign before the 5 because 5 came before the letter, before the variable. So we must also divide. It's the same thing, just like the example before. Because 5r means 5 times r, which means r times 5. So the 5 is multiplied on the left right here. To go to the other side, we have to do the opposite, which is division. So we can rewrite this as r equals 15 divided by 5. r equals 3. So it's exactly the same as the one above. The only difference is before I told you r times 5 equals 15. This time I told you 5r equals 15. Now let's do another one that's more difficult that involves fractions. Take a look here. What if I say q times 3 over 2 equals 1 over 4? Remember, I want to get q equals something. So I need to get rid of the times 3 over 2 right here. Times 3 over 2 goes to the other side of the equal sign as divided by 3 over 2. I can now rewrite this equation as q equals 1 over 4 as it is, divided by 3 over 2. Now remember, how do we do division when we have fractions? Here's how we do it. Q equals, keep the first fraction as it is, 1 over 4. Change the division sign into a multiplication sign. Then flip the numerator and denominator of the second fraction. So instead of 3 over 2, it's 2 over 3. This is called the reciprocal. 2 over 3 is the reciprocal of 3 over 2. Okay? This is how we do division with fractions. Q equals 1 over 4 times 2 over 3, which means that Q equals 1 times 2 is 2, multiply the numerators, over 4 times 3 is 12, multiply the denominators. Q equals 2 over 12. You can simplify this further, making Q equal 1 over 6. So Q equals 1 over 6. Now, let's do the same question, but instead of Q times 3 over 2, I will call it 3 over 2 Q equals 1 over 4. Now, remember like we did before, 3 over 2Q means 3 over 2 times Q. And any number times Q is the same thing as Q times the number. Just like we did a little while ago. Look here, let's remember together. We said that R times 5 is the same as 5R. So right here, when I say 3 over 2Q, that means Q times 3 over 2. So we need to get rid of the 3 over 2. But there is no sign before it. Remember, it's the same thing as saying Q times 3 over 2. So 3 over 2 is multiplied on the left. When it goes to the right side, we change the multiplication into division. So instead of 3 over 2 times Q, Q times 3 over 2, same thing, we move it to the other side as divided by 3 over 2. Now we have Q equals 1 over 4 divided by 3 over 2. Remember, how do we divide fractions? First one, change the division to multiplication, flip the second one. Here's your answer. 1 times 2, I multiply the numerators, over 4 times 3, multiply the denominators, so it's 2 over 12. You can simplify that further to 1 over 6, just like the one we did before. How do we solve a question like this? Remember, when you have something like this, you ultimately want to find what x equals. So we need to get rid of anything next to the x. Here next to the x we have divided by 6. Divided by 6 moves to the other side of the equation, to the other side of the equal. And instead of divided by 6, we have to change its sign. And the opposite of division is multiplication. So it changes into times 6. So we can rewrite this as x equals 2 times 6. X equals 12. Easy? Super easy. Now, remember that we can also rewrite x divided by 6 as x over 6. So I can get the question like this. X over 6 equals 2. What's the meaning of over 6? Over 6 means divided by 6. So it goes to the other side as times 6. So remember, x divided by 6 is the same as x over 6. X equals 2 times 6 equals 12. Easy? Super easy. Let's take another question. Here's another one. What if I told you that x over 12 equals 10? X over 12 means x divided by 12. We need to get rid of the over 12 or the divided by 12. Move it to the other side of the equal sign. It changes into times 12, making x equal 10 times 12, x equals 120. Let's take a harder question right now. What if we have fractions? What does that mean? Take a look here. What if I tell you x over 3 over 2 equals 5? Now, I will take all of this and move it to the other side because I want to get rid of anything with x. Over 3 over 2 is just like saying over 4, over 5, over a, over b. It's x divided by something. This something here is called 3 over 2 in this example. We're going to move it to the other side. Instead of over, which is divided, we will change that into times. What about the 3 over 2? We just put it the way it is because it's something. It's like saying x over a equals 5. Let's say I have something like this. X over a equals 5. Over a means divided by a. We move that to the other side as times a. That means x equals 5 times a, right? So x over 3 over 2 right here, let's go back to the left. 3 over 2 goes to the other side as times 3 over 2 instead of divided by 3 over 2. On the left, it goes to the right as times 3 over 2. So we're left with x equals 5 times 3 over 2. Multiplication of fractions. We multiply the numerators together. 5 times 3 is 15. Multiply the denominators together. 5 has a denominator of 1 because it's not a fraction. So it's going to be 15 over 2. And that would be your answer. Let's answer this question together. Before we do, let's revise really quickly. We learned together before how to answer a question like this. X plus 3 equals 5. We said we would simply move the plus 3 to the other side of the equal sign as minus 3, leaving me with x equals 5 minus 3, which equals 2. Very easy. We also learned, let me change the color here, how to answer a question like this. 2x equals 10. We said that 2x means 2 times x, which means x times 2. So the 2 right here is multiplied. It goes to the other side of the equal sign as divided by 2. So we can rewrite this one as x equals 10 divided by 2, which equals 5. How is the question on the left different from these two? It's different because here we have something multiplied by x and we have something added to that x. So it's actually combining the two concepts we learned on the right before. How do we do this? Well, it's very simple. First step, you need to get rid of the pluses or minuses. So 2x means 2 times x. So we just leave 2x as it is, meaning we want to find out what 2x by itself equals. We want to get rid of anything that is plus or minus the x. So we want to get rid of the plus 3. Plus 3 goes to the other side of the equal sign as minus 3. 15 minus 3. Okay? So we rewrite this as 2x. Remember, I didn't touch the 2. So 2x is just as it is. Equals 15 minus 3. Now what do? We answer this. 2x equals 12. Are we done? Is the answer 12? No. Remember, your final answer has to be x equals what? I'm trying to solve this equation, trying to find the value of x itself. Now we take this to the second step. Second step is to get rid of the times and the divided. Any number that is multiplied or divided by the x, the variable I'm looking for. Here I have 2x equals 12, just like here I had 2x equals 10 on the right. Go back to the left, please. Now let's take a look. Here I want to get rid of the 2. 2x means 2 times x, which means x times 2, so it goes to the other side of the equal sign as divided by 2. The opposite of multiplication is division. So we can rewrite this as x equals 12 divided by 2. X equals 6. That is your final answer. Let's recap really quickly. 2x plus 3 equals 15. This is what I had originally. I want to get x equals something. In order to do that, I must get rid of anything next to the x. In this case, I have two things next to the x. I have something that is added or subtracted, which is the plus 3, and I have something that is multiplied or divided, which is the times 2. I can't get rid of both in one step. I need to do this in 2 steps. First step, I got rid of the plus 3. Second step, I got rid of the times 2. I did this 2 steps, got the final answer for x. Easy? How do we answer a question like this? Remember, we always want to get x on the left-hand side equals a number on the right-hand side of the equal sign. Right here, I have my x's on the left, and I have numbers or a number on the right. So it's looking good. But I have things on the left. I don't have an x by itself. I don't have numbers that are multiplied or added or subtracted as we had in simpler examples before. So the first thing you need to do when you have parentheses like this, when it's already factored, is you need to expand. So step number 1, we need to expand in order to get the x by itself. So 3 times x plus 4 is 3 times x plus 3 times 4. Okay, I just expanded. 3x plus 3 times 4 equals 16. So 3x plus 12 equals 16. Super. Now this is going to be easy. I need to get rid of the pluses or minuses first. Remember, we said always get rid of the plus or minus first. So the plus 12 goes to the other side as minus 12. Good. Rewrite. Always write every step. 3x equals 16 minus 12. Super. That means 3x equals 4. Excellent. Now what? Now get rid of the multiplication or division. 3x is 3 times x is x times 3. So to get rid of the 3, we have to move it to the other side as divided by 3. Okay, because 3x is 3 times x, x times 3, same thing. So the 3 is multiplied on the left, goes to the other side as a division. Rewrite again. We have x by itself now equals 4 over 3, which is 4 divided by 3. Same thing. Got the answer. Super easy, super easy. Now let's do one more that looks similar to this one. But let's use fractions this time, okay? Now, here's a question. 1/3 d plus 6 equals 15. Let's answer this. First of all, if you have parentheses on the left, if you have factors on the left, then you must first expand. So number one, expand. 1/3 times d plus 6. So we do 1/3 times d, which is 1/3d, plus 1/3 times 6 equals the 15 as it is. 1/3 d plus 1/3 times 6 means 6/3, and 6/3 is 2, equals 15. Now it's looking like a normal equation. Okay, first get rid of any pluses or minuses with the d, with the variable. What is the plus or minus I have here? I have plus 2. Want to get rid of it, moves to the other side as minus 2. Good. Now we can rewrite 1/3 d equals 15 minus 2. That means that 1/3 d equals 13. Super. Now what do? We need to get rid of the multiplication or the division with the variable, with d. Here I have 1/3. All of this I'm going to consider it one thing, one number. D, which means 1/3 times d, which means d times 1/3. So it's multiplication on the left, moves to the other side as divided by 1/3. Now you can rewrite this. Let's rewrite it here. We have 1/3 d equals 13, okay? We said we're going to move the 1/3 to the other side. It was multiplied on the left, so it goes here as division. So my answer is d equals 13 divided by 1/3. Okay, remember, when we want to divide by a fraction or divide fractions, here's what we do. We go d equals first number, which is 13. Change the division to multiplication, okay? And then flip your fraction, reciprocal. So instead of 1/3, it's 3/1. So d equals 13 times 3 over 1 times 1, because 13 is 13/1. What is 13 times 3? It is 39. Now, you always want to check to make sure you did the right thing and got the right answer. So let's check really quickly. D equals 39. I want to check that I'm right. I take it, and I go up here, and I put it into this equation. Okay? My equation was 1/3 times d plus 6 equals 15. Well, let's see. If I put d as 39, it becomes 1/3 times 39 plus 6 equals. It says 15. I want to check, make sure it does equal 15. 39 plus 6 is 45. 1/3 times 45, they say equals 15. Let's check. 1/3 of 45 is 45 divided by 3, which is 15. So yes, 15 equals 15. So d equals 39. I was right. Now let's look at a difficult question like the question you have right here. This question is difficult because it doesn't look right. You have x's on the left and you have x's on the right. I have minus 2x on the left and I have x on the right. And the right way for any equation to look is to have all the x's on one side and all the numbers on the other side. I ultimately want x to equal a number. So I need to rearrange this equation. I need it to look good. And remember, a number one math rule that you should always use, whatever grade you're in, whatever math problem you're answering, is to always try to rearrange the equation so that it looks right, so that it is clean, neat, and ordered correctly. So here are a few tricks, a few things we can do in order to make this look better. First of all, if you find that the left-hand side has a negative with the x, and the right-hand side has a positive before the x, or nothing because x plus 16 just means positive x plus 16 because we can flip it as 16 plus x, right? X plus 16 is the same as 16 plus x. So the x on the right here is positive. What do I do when I have something like this? There's a little trick here. Remember how we used to move things from one side of the equal sign to the other by changing the sign that came with it? So the plus 3 moves from here to here as minus 3. Remember that? Okay. This is true. To move one thing from one place to the other across the equal sign, across that bridge, we need to flip its sign. However, if we move everything on the left-hand side and bring it to the right-hand side, and at the same time move everything on the right-hand side and bring it to the left-hand side, everything, not just one or two pieces. In this case, we do not change the signs of anything. It's just like saying that x equals 2 or 2 equals x. It's the same thing, okay? Now, in order for it to look better, I want my positives to be on the left, and I want any negatives to be on the right. And when I say positives and negatives, I am talking about the variable, the x. So what I can do as a first step is I can just switch the left and right. Remember, this only works if you switch everything on the left and everything on the right. So instead of 10 minus 2x equals, I'm going to keep it equals 10 minus 2x. I moved all of 10 minus 2x to the other side. At the same time, you have to move everything on the right and bring it to the left. So x plus 16 moves to the left. Now it looks better. Why? Because the positive x's, which is the x right here, is on the left. Are on the left, but it's only one, so it is on the left. And the negative x's are on the right. The negative 2x is on the right. One more time, guys, please make sure you understand this. If I just move a part of the equation from one side to the other, I have to change its sign. But if I move the whole left-hand side to the right and the whole right-hand side to the left, I don't change any signs. Okay, now let's take a look. I want to get all my x's on one side. In order to do that, I must get rid of the minus 2x from here and move it to the other side by itself, so that the minus 2x goes on the left, because I want all my x's on the left. Good. Now, minus 2x goes to the other side as plus 2x. Remember, because we're only moving a part, we have to change its sign. Now rewrite. And remember, in math, it's always best to write every step. Don't try to do 2 steps in one line. You'll usually get something wrong. So we rewrite this. X plus 16 plus 2x equals 10. Okay? I got rid of the 2x, negative 2x from the right, moved it to the left, changed its sign to plus 2x. Super? Super. Now what do we need to do? Well, I want only x's on the left, and I want numbers on the right. So I need to get rid of the plus 16 right here. It has to move to the other side of the equal sign. Plus 16 goes to the other side as minus 16. Super. Rewrite again. So x plus 2x, because the plus 16 flew away, equals 10 minus 16. Easy? Super easy. Now what? Let's combine. X plus 2x is 3x equals 10 minus 16 is negative 6. So I have 3x equals negative 6. Okay, I just want x by itself. So what do I need to do? I need to get rid of the 3. What is the meaning of 3x? 3x means 3 times x, which means x times 3. So it moves to the other side as divided by 3. This gives me a new equation, x equals -6 divided by 3. Okay, 6 divided by 3 is 2. There's a negative sign, and if there is one negative sign in the division or multiplication, then the answer has to be negative. So the answer is x equals -2. Of course, don't forget that you can always, and you should, test your answer. Take x equals -2, go to the original question, plug it in, and make sure you get the same answer on the left and on the right. Super? Super. Let's learn about inequalities. First of all, just as the name suggests, inequality means not equal. Remember when we learned how to solve equations, we said that an equation is something that has an equal sign. So if I have x plus 3 equals 5, for example, this is called an equation because it has an equal sign. An inequality, on the other hand, does not have an equal sign. This means that the left-hand side and the right-hand side do not equal each other. Instead, the left-hand side and the right-hand side have a relationship of greater than or less than. So, x is greater than 3. This means that x does not equal 3. X is greater than 3. It's 4 or 5 or 6, for example. If we say x is less than 3, that means that x does not equal 3. It is less than 3. It is 2. It is 1. It is -1. It is 0. Okay? Super. We also have two more signs that we use, which is this sign right here, and this basically means that x is greater than or equal to 2. You see how there's a dash? This is like an equal sign that's tilted to the right. So x is greater than or equal to 2. In this example right here, x equals 2 or is greater than 2. So 3 or 4 and so on. Super, super easy. Now, we can also have a fourth sign, which is called x is less than or equal to 5, for example. This means that x can equal 5 or can be less than 5. So it can be 5 or 4 or 3 and so on. Of course, we can have decimals, we can have other sorts of numbers, but I'm just making this as simple as possible. So, inequalities, x is greater than a number means it's bigger than that number. X is less than a number, smaller than the number. X is greater than or equal to the number, it's either equal or more. X is less than or equal, it's either equal or less. Now, we're going to basically solve inequalities using the exact same methods we learned for solving equations. There's only one little difference. Other than that difference, everything is pretty much the same. Let's take a look. Here's an example that we know how to do with an equation. X plus 3 equals 5. We used to say, okay, let's get rid of the plus 3. We move it to the other side as minus 3. Now I have x equals 5 minus 3, so x equals 2. Very good, very easy. Can we do the same thing if we have an inequality this time? Take a look. X plus 3 is greater than 5. What do I do here? The greater than sign is pretty similar to the equal sign in the equation. So all I do is I say, I want just to have x's on the left and numbers on the right. So I need to get rid of the plus 3. So I move it to the other side as minus 3, just as I used to do in equations. This leaves me with x is greater than 5 minus 3, which means x is greater than 2. So my final answer is x is greater than 2. Easy? Easy. Let's take another example. X minus 4 is less than 5. Okay, well, this looks pretty easy. How did we used to do something like this when it was an equation? Here, let's do it here on the side. X minus 4 equals 5. We used to say, let's get rid of the minus 4 because we just want x on the left. Goes to the other side as plus 4. That leaves us with x equals 5 plus 4, so x equals 9. Super. Now let's do pretty much the same thing with the inequality right here. I want to get rid of the negative 4 of the minus 4 right here because I just want x on the left. Move it to the other side. It goes as plus 4. That leaves me with x is less than 5 plus 4, which means x is less than 9. Easy. Okay, let's go further. Here we did 1 with a plus. Here we did 1 with a minus. Let's do 1 with multiplication and 1 with division. Okay, go to the right of the page, please. When I had 3x equals 12, how did I used to do this when it was just an equation? Simple. 3x means 3 times x means x times 3, so it's multiplication. I want to get rid of the 3. What do? I move it to the other side. Instead of 3 times x, x times 3, it goes as divided by 3. So I have x equals 12 divided by 3, so x equals 4. Good. Now, let's take the same numbers that we have here, but this time, let's make it into an inequality. What if I have 3x is greater than 12? I do the same thing. I just want x on the left, so I need to get rid of the 3. Okay, 3x means 3 times x means x times 3, so it moves to the other side as divided by 3. Okay, this gives us x is greater than 12 divided by 3. X is greater than 4. Easy. Let's do one more now involving division. Do it on the right first with me, please. Let's go on the right. What if I had something like this? X over 4 equals 5. Remember, we want the x by itself, so we have to move the over 4. Over 4 means divided by 4. So it goes to the other side. The opposite of divided by 4 is times 4. So I have x equals 5 times 4. X equals 20. Let's do the same thing right here, but with an inequality this time. I have x over 4 is greater than or equal to 5. Okay? Same thing. Inequality. You can use greater than, less than, greater than or equal, less than or equal. Same thing applies. Okay. Now I want to get rid of the over 4 because I just want x by itself. Over 4 means divided by 4, goes to the other side. Opposite of division is multiplication, so it goes as times 4. That leaves me with x is greater than or equal to 5 times 4, which means that x is greater than or equal to 20. Simple, easy, very easy. How do we solve a more complicated inequality like this one? Now, remember, when we used to do something like this when we had an equation, this is what we used to do. Go to the right, please. 3x plus 5 is less than 23. This is the question I have now. Now, I'm going to rewrite this just like we used to before when it was an equation. So now I have 3x plus 5 equals 23. Okay? First thing, I need to get rid of the pluses and minuses, remember? So I need to get rid of the plus 5 first. Plus 5 on the left goes to the other side as minus 5. Okay, now rewrite. 3x equals 23 minus 5. That means 3x equals 18. Second step, I get rid of the multiplication and the division. Right here I have 3x, which means 3 times x, which means x times 3. That means the 3 is multiplied by x, so it goes to the other side as divided by 3. Rewrite. X equals 18 divided by 3. X equals 6. Now, move on to the left, please. I want to do the same thing right here with my inequality. I will do the exact same thing. Instead of equal, I have less than. So, get rid of the pluses or minuses first, always. So the plus 5, want to get rid of that. Goes to the other side as minus 5. Rewrite, please, because you need to be organized. 3x less than 23 minus 5. 3x is less than 18. Now we want to get rid of the 3 because we just want x by itself. 3x is 3 times x is x times 3, so it goes as divided by 3. Okay, this leaves us with x is less than 18 divided by 3, which means x is less than 6. Easy. Super easy. Okay, let's do one that's a little bit more difficult. What if I have something like this? 3x plus 6 is less than 2x plus 15. Okay, now, why is this a little bit more complicated? It's a little bit more complicated because we have x's on the left and on the right, and we do not like the way this looks. We always want to have x's on the left only and numbers on the right only. So, the 3x on the left is fine now. I just need to bring the 2x from here to there. Okay, remember we did something like this before when we had equations. We basically said that we can take all of the 2x as it is, move it to the other side. Here 2x does not have a minus sign before it. That means it is positive. So when it goes to the other side, you have to change its sign. So instead of positive 2x, it becomes minus 2x. Now rewrite. So we have 3x minus 2x. Okay? Now, I got rid of the 3x. I got rid of the 2x right here. I rewrote them. Plus 6. Now this is over. Put the less than sign. Over. You're left with plus 15, which just means 15. Positive 15. Okay? Good. Now it's looking better. Combine like terms, please. We have 3x minus 2x, which equals x. Plus 6 is less than 15. Okay, looks easy now. Need to get rid of the plus 6 because we just want x on the left. Plus 6 goes to the other side as minus 6. So we rewrite. X is less than 15 minus 6. That means x is less than 9. Easy? Super easy. Okay, let's take another question that is not as difficult as this one, but looks a little bit complicated. Here's one more example for you all. What if I have something like this? 3 over 4 r plus 2 is greater than or equal to 3 and 1 over 2, 3.5. Now, looks a little bit complicated. Let's do this. First of all, you always want your variables on the left. Your x's, your y's, your a's, your b's, your r's on the left, and your numbers on the right. And here we only have r on the left, no r's on the right. It's a better question. It's easier. Okay, let's do this. 3 over 4r plus 2 is greater than or equal to 3 over 2. Okay, we want to get rid of the plus 2, and the 3 over 4. But remember, we always get rid of what first? Pluses and minuses. So get rid of the plus 2 first. Plus 2 goes to the other side as minus 2. Always rewrite. You need to be neat in order not to make mistakes. 3 over 4r. Plus 2 already went. Greater than or equal 3.5 minus 2. Okay? Super. 3 over 4r is greater than or equal to. How do I do 3.5 minus 2? There are many ways. One of the ways is to change 3.5 into an improper fraction first, and then change 2 into a fraction, and get a common denominator, and subtract them, and that just takes a lot of time. The other way is to simply think of it this way. 3.5 means 3.5. Minus 2. Okay, take away the 2 from the 3. You have 1. What about the half? It's still there. So it's like saying 3.5 is 3 plus a half minus 2. Okay, 3 minus 2 is 1. What about the half? It's still there. So the answer is going to be 1.5. Easy. Now what do? We want to get r by itself. In order to get r by itself, we need to get rid of the 3 over 4. 3 over 4 is the multiplication or division. Remember the second step. 3 over 4 times r, which means r times 3 over 4, goes to the other side as divided by 3 over 4. Now I rewrite this as just r, because I got rid of the 3 over 4, is greater than 1.5 divided by 3 over 4. Okay, now let's pause for a moment. You cannot divide fractions if one of them is a mixed number and the other is just a regular proper or improper fraction. You cannot. Actually, you can, but it's going to be a little bit complicated. In order to do this properly, you must first make sure that both fractions are fractions, no mixed numbers. So I need to change the 1 and 1 over 2 into a fraction, an improper fraction. Remember how we used to do this? We go 1 times 2, the whole number, times the denominator, 1 times 2 is 2, plus the numerator, plus 1 is 3, over the same denominator. So it's 3 over 2. Of course, if you're smart, you know that 1.5 is 3 over 2. 3 divided by 2 is 1.5. So you can just write 3 over 2 right away. Now it becomes 3 over 2 divided by 3 over 4. Now I'm going to rewrite this up here. Let me just move it with an arrow so that it looks good, nice and neat. Always be neat in your math. It's going to make life much easier. So we have r greater than or equal to 3 over 2 divided by 3 over 4. Now, remember, how do we do division? We do division with fractions the following way. R is greater than or equal to 3 over 2 as it is. Change the division into multiplication, right? And then flip the fraction. 3 over 4 becomes 4 over 3. This is called the reciprocal, remember? Super. Now, there are two ways to do this. The usual way is to multiply the numerators together. So we get 12, 3 times 4 is 12, over 2 times 3 is 6, so it's 12 over 6, and then simplify. The other way is to simplify right away before multiplying. Any numerator and any denominator that are the same can just cancel out. So 3 and 3 right here can cancel out together, leaving you with 4 over 2, which equals 2. Or you can multiply, get 12 over 6, which equals 2. I'm just going to use the normal way so I don't confuse you if you don't know how to simplify numerators and denominators yet. So r going to be greater than 3 times 4, multiply the numerators, over 2 times 3, you multiply the denominators. R is greater than or equal to 12 over 6. 12 over 6 is just 2. So r is greater than or equal to 2. Okay? Super. Inequalities are very similar to equations. And like we said before, when we solve inequalities, we basically use the same skills, the same hacks, the same ideas that we learned when we used to solve equations. So just as a quick reminder, if I was able to say that x plus 5 equals 7 in an equation before, and I get rid of the plus 5, making it minus 5 on the other side, leaving me with an answer of 2, I could simply do the same thing if it were an inequality. So if I had x plus 5 is greater than 7, I would simply say that x is greater than 7 minus 5, x is greater than 2. Look how similar they are. There is no major difference. The only difference between inequalities and equations in the way we solve them is if we have the negative trick. What is the negative trick? Take a look here really quickly. In equations, I could say that negative x equals 3. Well, I don't like the way this looks. I want it to be just x equals, positive x equals. I don't want it to be negative x equals. Well, you can simply flip the sign, making it x equals negative 3. So negative x equals 3 is the same as x equals negative 3. However, can you do the same thing with inequalities? No, you cannot. What does that mean? If I tell you that negative x is greater than 3, okay, easy. Can you say that positive x is greater than negative 3, just like I did here on the left in black with the equations? No. Why? Well, because on the left, you simply had an equal sign between the two numbers. So you switched the positives and the negatives, and you kept the equal sign as it is. But right here on the right in green, this is an inequality. It's greater than or less than. There is a different relationship here. It's not equals. So when you have a negative and a positive that you will flip, you'll make this positive and this one negative, you must also flip the sign in the middle. So negative x is greater than 3 becomes positive x, negative 3, but you have to switch the sign. So it becomes x is less than negative 3. Okay, a couple of examples here. This is easy. Let's take a quick one. If I tell you that negative r is greater than or equal to 5, I want to know what r is. R is negative 5. What is that? Wait a minute. I just switched the sign. Negative r and 5 became positive r, negative 5. But I must also switch the relationship between them. So negative r is greater than positive 5. Positive r is less than negative 5. What about the equal right here? No problem. It's greater than or equal. It became less than or equal because the equal doesn't really matter. Another easy one really quickly. Negative y is less than or equal to 2. Okay, positive y, negative 2. But remember, you have to reverse the sign. Super. Okay, let's take this a step further. Still very easy. What if I have an inequality like this? And I tell you that 6 minus 2r is greater than 10. Okay? First things first. I want to get rid of the thing that is added or subtracted to the variable, to the r. Here it's 6 minus 2r, so I want to get rid of the 6. Is there a sign before the 6? No, there is not, which means it is plus 6, positive 6. So it goes to the other side as minus 6. Okay, now it becomes negative 2r, because the negative right here doesn't move. It stays with the 2r. Positive 6 went as negative 6, so greater than 10 minus 6. See here, I didn't change any signs because I didn't switch, I didn't flip the positives and negatives. I just moved a number from one side to the other, which is completely normal. Negative 2r is greater than 4. Perfect. Now, I want to get rid of this negative. I want to get rid of it now, right now. I can get rid of it at the end, but I want to get rid of it now. What do? Now, most teachers are going to complicate this. They're going to say you got to get rid of the -2 first altogether. You have to multiply both sides by -half. It's going to be complicated. Here's what I do. Simply I say, I want to get rid of the negative right here. So I just want it to be 2r, positive 2r. If I do this, I need to change the 4 into -4. Okay, but don't forget, since I switched the negative signs on both sides, again, I didn't move any numbers here. I just multiplied the whole left-hand side by -1, and I multiplied the whole right side by -1. I didn't tell you I multiplied, I just switched or flipped the negative sign, okay? I did not move a number from one side to the other. That's different. So right here, I need to change the relationship. So it becomes positive 2r is less than -4. Now, let's get rid of the 2 times r. 2 times r means r times 2 goes to the other side as divided by 2. This leaves me with positive r is less than -2, because -4 divided by 2 is -2. Here's my answer. Super? Super. Wait a minute. Can I test this? Can I check that I'm right? Yeah. How? With an inequality? Yes. Here's how. R is less than -2. That's your answer. So you have to assume that R equals any number less than -2. What is less than -2? -1 or -3? -3. Because -2, -3, -4, -5, it keeps going smaller, less. So R equals -3. I'm going to test. Okay? Now, take this r equals -3 and put it into the original. 6 minus 2r is greater than 10. Okay, perfect. 6 minus 2 times -3, because r here in my assumption is -3, is greater than 10. Okay, so it's 6 minus 2 times -3 is positive 6, greater than 10. 6 plus 6 is 12. Is 12 really greater than 10? Yes, it is. So I'm right. Easy? Easy. Graphing inequalities. Graphing inequalities is very, very simple. Now, here's a number line, and let's take a couple of inequalities and look how the graph is going to look like for each. So, let's take this one first, an easy one. X is greater than 0. We go to the 0, to the number we have in the inequality. And you start above that 0. You draw a line either to the right or to the left. If it's greater than 0, that means it is bigger than 0. So it's 0. No, it's not 0. It's bigger than 0. So it's 1, 2, 3. So it's bigger than 0. So we draw the line like this, and we put an arrow. This means that the value of x is greater than 0. But there's one little thing we still need to do. We ask ourselves, is x equal to 0 a possibility? Can x equal 0, or is it only greater than 0? Right here we have x is greater than 0. So at the 0, on the line we drew, we draw an open circle. This means x is greater than 0. Okay, just to make sure you understand this. What if I have x is greater than or equal to 0? I do the same thing exactly. Start at the 0 on top. We go to the right because it's greater than 0. But now, can 0 be a value of x in this inequality in green? Yes, because it says x is greater or equal to 0. So on top of the 0, on my green line, I have to put a solid circle. Can you see the difference between the green and the black lines? The black line has an open circle. It doesn't look really open right here. Let me make it look better here so that you can actually see exactly what I mean. I'm going to try to move this a little bit. There you go. Okay, now it looks better. We have an open circle, black. That means x is greater than 0. We have the green one. It's just a solid circle, which means x is greater than or equal to 0. Let's take a couple more examples really quickly. Let's say I have x is smaller than -1. Start at -1 right here, okay? Smaller than -1. That means that x is less than -1, and when you have negative numbers, the less you go, the more you move to the left. So -2 is smaller than -1. -3 is smaller than -2. So I'm actually moving to the left, and I put my arrow. At -1, is x equal to -1? No, because it says x is less than -1. It doesn't say anything about being equal. So we put an open circle on top of -1. Okay, just to make sure you understand this, let's do one more in blue. What if I have x is less than or equal to -2? Start above -2, so right here, less than -2, so we're going to the left. If it's less than, we move to the left. If it's more than, we move to the right. Can x equal -2 in this example in blue? Yes, because x is less than or equal to -2. So we need to draw a solid circle on top of -2, just like this. Easy? Easy.